Okay, so the purpose of this video is to exercise on invertible matrices. Um, let's start. So the question says that we need to prove that if A is a real and invertible matrix, then we can conclude, we need to show this, that A transpose plus A transpose A is also invertible matrix. Okay, so how we will do this? We will start by showing that the kernel of A transpose plus A transpose A equals 0. And how can it help us? So let's start with saying that see that A is invertible, namely A is a squared matrix because invertible matrices are squared. Therefore, if we look at A transpose, it must be squared, and also A transpose A must be squared. The addition of squared matrices is a squared matrix. Therefore, A transpose plus A transpose A is a squared matrix. Now we are taking the kernel. Why? The idea is that we look at the homogeneous system of A transpose plus A transpose A, and we want to show that to the homogeneous system of this squared matrix there is only one solution, the trivial solution, the solution x equals 0, and a squared matrix which for the homogeneous system there is only one solution, the trivial solution, is by definition the invertible matrix. Not the invertible matrix, but an invertible matrix. Okay, so how can we do it? Let's look at the solutions for the homogeneous system, for the kernel. So let's look, let x be some vector in Rn, yes, such that he is a solution for the homogeneous system A transpose plus A transpose A times x equals 0. Now it's some x. It doesn't must to be 0, it's some x, and we will show that x must be equal 0, and therefore there is only the trivial solution to the homogeneous system, and therefore this squared matrix must be invertible. Okay, so if we say that this equals 0, yes, so let's look at the inner product of this system, A transpose plus A transpose A x, which is 0, with the vector x, with the vector x. So this is 0. This is our assumption. So inner product with a 0 must be 0. So we can say that it must be equal 0 on one side, and on the other side we can look at it like this: A transpose x plus A transpose AX x. Now I can look at this as an inner product, and I can divide this to look like this: A transpose x plus A transpose A x, right? It's the inner product properties. So what can we do now? What we can do now is look at the conjugate. Yeah, if we have some transformation or some matrix txy, I can say that it equals x conjugate y, right? This is in the complex, and in the reals, I can say that it's tx equals x t transpose y. Okay, this is in the real part for the definition of the conjugate, and we are on the real part because by the definition of the questions or the question, a is real. Therefore, I can use it. Let's use it and say that, for example, this equals a transpose x, a transpose x, right? I took the a and put it here with the transpose. The same thing goes here, plus ax, ax. Again, I took this, put it here, and do a transpose. A transpose on transpose, it's again the original matrix. Okay? So from the transpose properties, we got this thing. Let's get on. Let's proceed. So what we have here, we have inner product of an object with itself, which means it's the norm of an object, and the norm, yes, in inner product is defined to be greater or equal of for 0 and 0 if x equals 0. Yes, for other x it's greater than 0. Okay, just a reminder. Now, so it's equals the norm of a transpose x squared plus a x squared, right? Because it's without a squared. It's without a square root. So this is greater or equal 0. This is greater or equal 0. We know that in the end, as we started with, it must equal 0. But because both are greater or equal 0, in order to equal 0, we must have that both of them equal exactly 0. Therefore, we also conclude, we conclude this, right? That both equal 0. Okay, but as we said, when an inner product equals exactly 0, when the object himself is 0, right? So we can conclude that ax equals 0. But we started with A. We know something about the matrix A. A is invertible, right? A is invertible. Therefore, the only solution for this system with an invertible matrix is x equals 0. What we started with, let x be some element in R, in Rn, and we concluded now that x must be 0. But what was x? X was the solution for the homogeneous system, this system, right? Therefore, for this system, for the homogeneous system, we have only the trivial solution x equals 0. And a squared matrix with the only trivial solution for the homogeneous system is by definition invertible. Therefore, we can conclude, as we needed, that this matrix A transpose plus A transpose A is invertible as needed. That's it. Thank you very much. If you have any correction or something like this, please let me know. And this is from the Open University, so thanks to them also. Credit to them. And